First thing that is really important to understand is your brain is developing at a massive rate at the beginning of life, in utero, as well as in the first 3 years of life. And to bring that on home, that you can look at this graph, which reflects it. But the greatest period of brain development is in utero, and brain development takes up 70% of the newborn's calories versus 18% in adults. The baby has 99.9% of their neurons at birth, and 20,000 new neurons each second are exploding, compared to, sadly, just 700 new neurons in a day for an adult. So in the first 3 years of your life, your brain develops to 90% of the adult size, with the majority of the systems and the structure that we need in place for all future emotional, behavioral, social, and physiological functioning during the rest of your life. The other thing to keep in mind in terms of the neurobiology of trauma is that our brain organizes from the bottom up and from the inside out. Okay, so we have sensory input that comes in, whether that's through our 5 senses outside of us: sight, smell, hearing, taste, touch, okay? Or also like what we experience internally, like hunger or thirst or a cramp in our leg or dropping something on our toe. I guess that's touch. Okay. So anyway, because that sensory input is coming in through the bottom of our brain, and because our lower part of our brain is our most primitive part of our brain. In fact, people tend to call it the lizard brain or your reptilian brain or your downstairs brain. It has lots of nicknames. But as a result, the thinking part of the brain is the last to get the message. And so if we are interpreting something as dangerous, then our lower part of our brain can respond to that before our upper part of our brain has a chance to turn off that alarm and say, nah, it's not a snake next to your canoe, it's really just a stick. But meanwhile, your heart has already started racing, you're paddling like crazy, you're probably screaming, and then your brain tells you it's just a stick. You can tell I grew up in the South near a river. I think probably the easiest way to make sense of this, and you have a slide that shows the hand model of the brain, but I'm going to show it as well, because I think this is something you can teach your kids as well. And in fact, your kids may have already been taught this at school, because a lot of teachers have gotten pretty savvy that this is a good way to help kids understand the way that their brain works. So this is a crude example, and any neurologists in the audience, feel free to correct me if I make any structural errors here. So if you imagine that you're looking back, this is from Dan Siegel, and it's called The Hand Model of the Brain. You can find it on YouTube as well. So if you imagine that here's your eyes right here, and you're looking into the back of your head, this is that lower part of the brain. This is your brain stem, this is your midbrain, and this is your limbic system, your thumb that's tucked in here, and then this is your cortex, okay? Your neo-orbital frontal cortex is right there in the front, right behind the eyes. That's kind of the CEO that is kind of the boss of the brain, right? So when we're regulated, our thinking part of our brain is integrating everything and able to tell that alarm, no biggie, we got this, all's well, right? When our limbic system detects danger from that sensory input, now keep in mind, we just gave examples of children that have experienced trauma. If they have a heightened stress response, that means the lower part of their brain is primed to look for danger. So their amygdala, which is basically the smoke detector or the alarm in your brain, is much more trigger happy and much more likely to say, emergency. And so then it's kind of like a spring. So your cortex gets a little hijacked here, because let's face it, if a lion came in this room right now, we would not be using our cortex. We'd be throwing chairs, we'd be screaming, we'd be doing all kinds of things, but we wouldn't be stopping and saying, I wonder if that's a domesticated lion, or did it escape from the zoo? but we would not be using our cortex. We would be full on, flipping our lid because we don't need to use that, and that's a waste of energy, right? Then if we discovered it was our boss in a costume, our cortex would turn the alarm off and we would think, wow, that was a really cruel trick, right? So, and then you have these chemicals, and y'all have heard of them: adrenaline, cortisol, dopamine, serotonin, norepinephrine. And without going into too much of a complicated explanation, that's kind of like a sprinkler system that's coming on and sending like amped up heart rate. And you can imagine that for kids that have that elevated cortisol and they're going through life like that because they don't have the sense that they're safe, this is why those are kids that have the ACEs scores where they're more at risk, because to live your life jacked up on cortisol puts you at significant risk for other health problems. So I'll say a couple more things about this just because I think it's interesting. So your amygdala is in your limbic system. Also, your hippocampus is in your limbic system. Your hippocampus is important because it's kind of like the librarian of your brain. It's like your cognitive mapper that tells your memories where to go in the library. There's 2 times that the hippocampus falls down on the job. One of them is in the first 2 years of life, and that's simply because it hasn't fully developed enough yet, which is why we don't have an autobiographical memory that we can share about our early childhood. We have memories. They're just kind of stored in our body, and we can't consciously access them because our librarian didn't put them where we know where to look in the library. The other time that the hippocampus falls down on the job, though, is in times of very high stress, which is why traumatic memories tend to not get stored in a way where we can kind of file them in the back of the library. So a lot of our trauma work is helping people make meaning of the trauma enough so that they can store it in the library so that they're not tripping up over it every time they come in. So the other thing, in terms of the hierarchy of brain function, so we have brainstem, midbrain, limbic system, cortex. Your brainstem is pretty much done developing by the time you're a baby, okay? And midbrain by age 2. Limbic system by age 6. I will pause and let you ponder a second as to when your cortex is done developing. There's the pause. But there's no audience here, so we'll just give you the answer. 25. So parents, sadly, most of you, your brain is done maturing. You can still learn things, but your cortex is not going to be growing and maturing anymore. But the good news is that when you're freaking out about, oh my gosh, my kid did this at age 8, what are they going to do when they're 17? That a lot of that, you have to remember their cortex is not even half cooked. And their cortex is the part of the brain that problem solves, makes meaning, puts on the brakes, helps with time management, helps, like, is this a good idea or a bad idea? So 8-year-old meltdown does not mean 25-year-old murderer. So if you look at the next slide that shows the scans, it kind of brings home just how detrimental early trauma is to brain development. The brain that you see on the right side is a child that had extreme neglect, and you will see that this child has enlarged ventricles and cortical atrophy. And the actual head circumference is only at the 3rd percentile. We can make some recovery up until age 4, but when someone has very profound neglect, particularly sensory deprivation, where they're not getting exposed to language and malnutrition, understimulation, no touch, that can causes permanent brain damage. There's plenty of facts I could give in terms of how, like trauma affects the brain. I would say that some of the most consistent research findings are that children with early trauma have an enlarged amygdala, and also a smaller corpus callosum. That's that part of the brain that helps the left and the right work together. Also lower intracranial and cerebral volume, elevated stress hormones, like 3 times higher PEA, high cortisol, low serotonin. And interestingly, when they've done a lot of the research in terms of early trauma on Romanian orphanages, actually, and they found that the size of the amygdala is actually proportional to how long a child is in institutional care. So the other thing that, I think this is a compelling statistic, that if you think about toxic lead poisoning, which is something that we know is detrimental to brain development with children early on in life, it's actually, when you compare high levels of domestic violence versus high levels of lead poisoning, the high levels of domestic violence has more than twice the amount of brain impact for young children under the age of 3. Lead poisoning has been overall a loss of 3 IQ points, and domestic violence exposure overall is a loss of 8 IQ points for children under the age of 3. So, and then I did include, this is from a book called What Happened to You by Bruce Perry, this chart that shows different states from calm all the way to terror, and it shows you different parts of the brain that tend to be in the driver's seat. There are 2 different kind of trends in response to trauma or really stress that people can take. They can either go the hyper-arousal or they can go the hypo-arousal. Hypo-arousal is more when you, at a smaller level, might be trying to kind of please someone if you felt in danger, and that could move towards collapse or numbing out or dissociation, checking out. That is more common with females, with young children, with medical trauma, or with traumas that you can't escape, such as being sexually trafficked, something like that, or kidnapped. So hyperarousal is probably what you think of more often when you think of a trauma response. That's when you tend to go into fight, flight, or freeze. We tend to, what Bruce Perry calls flock. That's when you get kind of vigilant, like, what was that noise, And then you might move to the freeze, kind of like the deer in the street. Bad survival skill for the deer there. Yeah. But, and then you would move to flight if you thought you could get away, and fight if you couldn't. So the hyperarousal tends to be more common for traumas where you have some kind of action involved in it, or if you're an observer, or if you're a male, or if you're an older kid. And then I'm going to turn it over to Karina, because I'm done talking about the brain.